Okay, so now let's see how we can convert negative decimal number to binary. See, there are 3 steps in order to convert negative number to binary. So I'll just quickly write the steps over here. So at first, what you have to do is you have to take magnitude of the negative number and you have to convert it into the binary. So this is step 1. So I'll write convert magnitude of the number to binary. Now what is magnitude of a number? Let's say the number that we have to convert into binary is, let's say, minus 15. Okay, this is the decimal number that we have to convert into binary. So its magnitude is going to be the positive part, or I'll say excluding the sign, whatever number we have, it's the magnitude. So in this case the magnitude will be 15. So basically whatever number we have excluding the sign, that we have to first convert into binary. This is step number 1. Second step is we have to take 1's complement of the binary. So I will tell you what is 1's complement. Let me just write the step. We have to take 1's complement of the binary. And third step is we have to add 1 to 1's complement. That's it. 3-step process, very easy. So let's start with minus 15. So what we have to do at step 1, so we'll first do step number 1. So in step number 1, we have to convert minus 15, or we have to convert magnitude of minus 15 into binary. So we have to convert 15 into binary. Let's quickly do that. So let's divide 15 by 2. 7 to the 14, we get 1 as a remainder. Then divide 7 by 2. 3 to the 6, we get 1 as a remainder. Then divide 3 by 2. So 2 ones are 2, we get 1 as a remainder. And divide 1 by 2, 0 we get as a quotient, and we get 1 as a remainder. So 4 times 1 we are getting as a conversion into 15. So I'll just write it over here, 1 1 1 1. So 1 1 1 1 is basically a conversion for 15, a binary conversion of 15. Now there is one important thing over here. See, what we have to do is whenever we are converting any number into negative, what we'll ideally do is we'll consider group of 8 bits. Okay, so right now we are just getting 4 bits. I'll append 4 zeros in front of this number. Let me just shift this number to little bit right side. So what I'll do is I'll append 4 zeros in front of a number. And yeah, now you can see that this is a group of 8 bits. So this is now 8 bits. So 8 bits is nothing but 1 byte. This is usually important. See, whenever you are converting negative number into binary, just try to form a group of 8 bits. Let's say after converting a positive number into binary, let's say you are getting 9 bits, then you are going to create one group of 8 bits, and you are going to create one more group of 8 bits, so it will be 2 bytes, something like that. I'll take one more example by which I'll explain that part as well. So right now just remember over here, you have to create group of 8 bits. So in this case, and always remember, you can add any number of zeros on the left hand side. It doesn't going to change value of the number. It's very similar to as we add zeros on the decimal number on the left hand side. It's very similar to that. So now we have to do second step, step number 2. So in step number 2, what we have to do is we have to take 1's complement. Now what is 1's complement? 1's complement is very easy. Wherever you have 1, you have to make it as 0. And wherever you have 0, you have to make it as 1. So over here we have 1, it will become 0. This one will become 0. This one will become 0. This one will become 0. These zeros will become 1 1 1. That's it. This is step number 2, right? So we have taken 1's complement. What is 1's complement? 1 will be converted to 0 and 0 will be converted to 1. Okay, now let's move to step number 3. What we have to do in step number 3 is we have to add 1 to the 1's complement. Now this is our 1's complement, so I'll just write it again over here. 4 times 1's followed by 4 times 0. We have to just add 1 to it, so I'll add 1 to this number. See, this is binary addition, not normal decimal addition. So I hope you know electronics a little bit, and I hope that you know how binary addition works. If you don't know how binary addition works, then maybe you can check it online. Okay, so 0 plus 1 will be 1, and that's it. I mean, on left hand side we have to take same digits down, so I'll write 000 and 4 times 1. So this is the binary equivalent of minus 15. So it's nothing but 4 times 1 followed by 3 times 0 followed by 1. Now always remember, whenever we write a positive number, let's say whenever we write positive 15, so what is positive 15? It is nothing but 1 4 times. Okay, so in case of positive number, you can literally add any number of zeros on left hand side. It's not going to change its value. You can add any number of zeros on left hand side in case of positive number. In case of negative number, you cannot add any number of zeros on the left hand side. In case of negative number, you should ideally add any number of ones, or you can ideally add any number of ones on the left hand side, and it's not going to change value of that number. This is very important point. Right now you may not be getting sense out of it, but this is very important. Always remember, in case of positive number, you can add any number of zeros on the left hand side, but in case of negative number, you can add any number of ones on the left hand side. This is very important point. I will explain this point to you once we'll look into, or once we'll start how we can convert binary number back to decimal. At that time you will get idea about this point. Right now just remember this concept. Now what I'll do is I'll take one more number for clarifying this concept a little bit, or just for practice. So we'll take one bigger number. Let's take 259 that we took last time for the positive number. So let me just clear out this board. Okay, so let's see what is binary conversion for minus 259. This is in decimal right now. We have to convert it into binary. So yeah, let's start dividing the number. Let's do step number 1, where we have to take binary of the magnitude of the number. So once we divide 259 by 2, so 2 ones are 2, then 2 to the 4, then 2 nines are 18, right? So we get 129 and we get 1 as remainder. See, 129 multiplied by 2 is nothing but 258. Then let's divide 129 by 2. So we get 64 as quotient and 1 as remainder. 64 2s are 128. Then let's divide 64 by 2. We get 32 as quotient and 0 as remainder. Then let's divide 32 by 2. We get 16 as quotient and 0 as remainder. Let's divide 16 by 2. We get 8 as quotient and 0 as remainder. Let's divide 8 by 2. We get 4 as quotient and 0 as remainder. Let's divide 4 by 2. We get 2 as quotient, 0 as remainder. Divide 2 by 2. So we get 1 as quotient, 0 as remainder. And let's divide 1 by 2. We get 0 as quotient and 1 as remainder. Once we get 0 as quotient, we have to stop. Alright, so now we have got a number. So let me write this number from bottom to top. So the number is 1 followed by 1 2 3 4 5 6, 6 times 0. So I'll just write 6 times 0 followed by 2 times 1. Now let's try to group it into 8-bit format, or let's group it into 8 bits. Okay, so, and always remember, the group that we have to make, that needs to be made from the right hand side to left hand side. So let's count the digits. 1 2 3 4 5 5 6 7 8. So this is one group of 8 bits, right? And this is another group, but in another group we just have one digit right now. So as this is a positive number right now, we are talking in terms of positive number, so we can add any number of zeros in the left hand side. So how many number of zeros we need to add over here? We need to add 7 zeros. So I'll write 3 zeros over here and then 4 zeros. So now we have added 7 zeros in the left hand side. So now we have two groups of 8 bits. Now let's perform step number 2. Let's take ones complement. So yeah, let's do it. So this ones complement of this will be 7 times 1. So I'll write 1 1 1 1 1 1 1. Then this one will become 0. So this is my group 1. And in group 2 we have 6 zeros followed by 2 ones. So over here we'll get 6 ones followed by 2 zeros. This is nothing but my ones complement. And let's do step number 3 now. In step number 3, what we have to do is we have to add 1 to the ones complement. So let's add 1 to the ones complement. So after adding 1 to the ones complement, the number that we are going to get is 4 times ones followed by 3 times ones followed by 0 followed by 6 times ones, 1 2 3 4 5 6 followed by 0, and 0 plus 1 will become 1. So this is the binary conversion of minus 259 in 16-bit binary format. So, okay, so we have written 16 bits for minus 259. So in this way, you can convert any negative number into binary. I hope now you are clear with the method. What is the method of converting a negative number into binary? First, you have to take magnitude of that number, and first you have to convert magnitude of that number into binary. After that, once you convert magnitude of that number into binary, you have to take ones complement of that number, and then after taking ones complement of that number, you have to add 1 to that ones complement. And always remember, whenever you are converting into a negative number, always try to create group of 8 bits. This is very important. Now in the next video, we are going to see how we can convert binary numbers back to decimal. So that's it for this video.